I should record this. So the body describes the experience. It's gonna be reflective. It's gonna ask questions. A good body to this particular format of a lab report is gonna show me that you're thinking about the experiment, that you understand what happened, that you saw what happened, you observed it, and you thought about why it happened. What did the temperature make a difference? We're not sure. Was the salt concentration different? Why did it turn yellow? Could have been the lavender oil. Why did my colleague flip the test tube on its side and let all the gas out? Possibly. Why don't you hand me that cell phone, dear? Just bring it to me, or hand it to me, whatever it takes. So, describe the experience and be reflective on the process. I love how I tell her to give me a cell phone. Like 3 people put their cell phones in the cubbies. It's hilarious. Yeah, I saw you too. She was actively texting when I was talking to her, so. And laughing about whatever was being texted to her or replying to. All right, anyways. Describing the experience and describing, trying to come up with questions, explanations about what you saw. It's not just what you saw, but just ideas. Now, in a true scientific lab report, we would separate the results or observations from the analysis. So this is going to be a combo of both. Since it's an observational lab, it's not an experiment. I just want to know what you were thinking. And then your conclusion. Your conclusion, I'd like to know if it worked. It worked great. How can you have improved it? How could you make it go faster? Because some people were saying it's taking too long. Could we make it go faster? Could we add more salt? Maybe that would make it go quicker. Could we have added Epsom salts without lavender? That might have made a difference. There's all kinds of things that you could think about. As you're sitting down thinking about this process and what you experienced, and come up with a conclusion. And then obviously the big part of the conclusion is answer this question, what did I learn? What did I learn from this? Right? And if you write, I didn't learn anything, well then you got the right grade. Congratulations, it's a 0. This is where you prove to me you learned something. That's gonna be key. That you learned something here, and obviously I spoke a lot more than I wanted to. So what you learned from this experiment, from all this that you just wrote, is going to be key to you getting your points. Yeah.
Are these like individual lab reports or as a group?
Individually, the observations can all be the same. You all saw the same. I'm assuming everyone saw the same thing. I will be sending you video of the ones that worked. So you can see evidence. When you write, especially the body, which is describing, you really want to point out this is what we observed, because these are facts, and this is evidence of. So, for instance, when we heard a pop, that was an evidence of gas expanding, or contracting. So we feel that a chemical reaction actually occurred. When you write things like there was no water on the inside of the test tube, after the pop, there was water on the inside of the test tube, we think that means that we reformed water. Our evidence is blah, 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 blah. So everything you write, you want to support with evidence. This is a science class. So that will give you even more points. Does that make sense? This is not a fantasy. This is not a literature class where you're writing a fantasy. This is you making observations, making conclusions, supporting your conclusions with evidence.
Does this go in our binder?
This is going to get turned in on Monday. Yes, I would put it in your binder. I would put it under whenever you finish it, put a date on it. But it gets submitted. It'll be due on Monday. Upload it. Or if you do it on, whatever. Are we good with this? Is that reasonable? On Monday, we're going to start a project. Here's my concern, and I'm going to let it go. It's going to be what it is. I have to let it go. I'm going to be very clear on this. We have to do a demonstration of learning. I gave you the date on that demonstration of learning. You will be presenting in front of experts. Miss Perez is going to ask the people on our board of trustees, which are people on medical school, from the medical school, from various different private companies, to come and watch you. And if you're distracted during the activity and you don't get your stuff done, I'll try to manage you and help you stay as focused as I can. But whatever happens on that day, whether you are successful and you do a great job and everybody loves what you did, or you're embarrassed, that's up to you. You will be making a poster. We will print those posters. You will be presenting those posters on that day. You will be dressed up. There'll be visitors that come with a clipboard, making notes, asking you questions. You will be describing what you did. And you'll get it all on Monday. All right? Okay, I think I've had plenty of patience with you. This is me speaking to you calmly. And no, it's not helpful. I could do it too. I could tell them to shut up, but they wouldn't listen. You're about to lose points. I see one person, Adam, with his hoodie on his head. He knows better. I see people talking that should be quiet. I'm asking you, let's take some notes. And then let me get you set up. Make sure you're doing this lab safely. It is a lab. You will have a mini lab report due on Monday. It's already in Schoology. I'll describe to you what the expectation is. It should be relatively easy. It will require you to write.
Do you want us to do this in Cornell notes?
Yes, I would do all my notes in Cornell Notes so that you can revise and reduce and reflect. Today is the 21st. It is. It's already the 21st. Isn't it amazing how fast it goes? Interim progress reports are here already. Very soon, the end of the quarters here. Grades are going to go in. Just like that, end of October. 1 month away, you got your first report card in high school. That's how quick it's going to go. Remember, October 10th, you have another notebook collection. All this is happening. These are things that you might want to write in your notes, right? So that you are clear that, October 10th, another notebook collection, and still people are talking. That's good. This is me trying to have patience. All right. So October 10th is another notebook collection. We know that. We know that the end of October is your first report card. All right, so that's a big deal. You know that October 10th, you have a visitor coming. If you've read what I've sent you, you've read the handouts, you know that all that is happening. So important dates. So when we look at today's lab, there's some stuff that we have to talk about that some people would assume you learned about. I would not assume that. We're going to do something called electrolysis. Electrolysis. So this is broken. I like to break words up. I like to look at them. It helps me when I'm reading to find root words. When I'm on a standardized exams, it helps me a great deal trying to break down words and try to find meaning in them. Lysis means to break up. And electro means the use of electricity. So you're going to use electricity to break up something. That's what electrolysis is. We're going to break up H2O. Notice I'm summarizing on the left. I'm reducing on the left. You might do it backwards, but in either case, you're reducing, making things make sense to you. So the next question that I have when I see something like this, when we talk about using electricity to break something up, I have to ask myself a question. And the question I ask is, when I'm looking at this, when I was thinking about how I would explain it, is what is electricity? And I could ask you guys right now. Let me go ahead and ask you. You guys, let me state first that many of you would just curl up and be lost if electricity stopped working. What would you do? It would be dark at night. You wouldn't be able to use your phones because your phones are almost everything you have runs on electricity. There's an old sci-fi movie called War of the Worlds. It was remade when you were just babies, but originally it was very old in the 50s, 60s. And not War of the Worlds, I'm sorry. It was The Day the Earth Stood Still was the name of the movie. It was remade recently, again, when you were kids. The alien ship lands, and in order to prove that they are aliens, that they have the power they have, they stop electricity from working for 1 hour on the whole planet. Everything stops working. Just like that. What would happen? And so my question to you is, what is electricity? It's that important to you, right? That some of you say you would die. What is this stuff that you call electricity you depend on so much? LYSIS means break up, to break up. LYSIS means to break up. So the question is, what is electricity? Let me be very clear that electricity is just a flow of electrons, a flow of negative charges. That's it. You get electrons to go, you get electricity. Just move them. All you're doing, everything you do when you're running an electric motor, electric car, or you're running your television, it's all about making electrons move. That's all you're doing. When we look at something like a current, and by the way, electrons, normally I like to make a little E with a negative sign, and sometimes I'll even make them yellow. I'll put a big yellow dot or a yellow dot, and inside the yellow dot, I'll write the letter E with a negative sign. It's just electrons, the easy way to write electrons, right? It's a negative charge. They're tiny, they have almost no mass, and they have a negative charge. That's all you have to think about them as. But a flow of these tiniest of particles, smaller than an atom, a flow of that runs your whole life. Your whole life is run by these tiniest of particles with a negative charge. It's insane how simple, how just a simple little thing like an electron, yes, bless you, I'm sorry, I was lost in thought. An electron, this tiny little negative charge, can influence your whole life. So we know about chemical bond, and by the way, when you think about the flow of electrons, we call the flow of electrons current. You've heard of current, right? The flow of electrons is current. If you have a strong current, like it would be probably you would say 120 A really strong current would be a 220, right? You have lines in your house. If you have a washing machine in your house, it probably runs off a 220 line. If most of your outlets in the house are 120, those giant power lines outside can run even more current, more flow of electrons. If that makes sense to you, I'm not going to worry about units right now. But just think about the fact that it's literally, think of a river, gentlemen in the back. Think of a river flowing water, but instead of water, think of electrons flowing. That's electricity. That's it. So when we look at bonds, what are bonds? What are chemical bonds? We look at water. We draw these lines. We've drawn them several times. Yesterday you had time to go over your notes and make sure you added everything you missed and you were supposed to turn it in. And you did an activity yesterday you're supposed to, and you're supposed to turn that activity in. And one of the big things was the use of these things called bonds, right? What are these bonds? What is that? These are bonds. What are they? Yeah. That's right. That's exactly right. That's good. That's good. You gave it a name. That's the beginning. It's a covalent bond. What does it mean to have a covalent bond? What does that mean? Thank you. Yes, sharing electrons. Sharing those tiny things that we know we're running through current through your walls, right? So sharing that makes a bond. So what we're going to do is we're going to take this bond. These three atoms are sharing these electrons, two bonds, two covalent bonds. By the way, let's make sure we understand. A molecule is, and I've said this before, but I'm going to say it again, is where two or more atoms share electrons. Where? Let me rewrite it. So when you have a molecule, that is two or more atoms sharing an electron. We call it a molecule. If they're not sharing electrons, it's not a molecule. That's it. I know it sounds simple, but you're going to see things. In fact, we're going to work with some stuff today. This bag is full of it. There's some people call a molecule that isn't. Because they don't share electrons. But we'll look at it in just a minute. All right, so are we good with that?
No, hold on.
Okay.
What if there's only one atom?
Then if there's only one atom, they can't share anything. All right? So you have to have two or more for them to share. If they're sharing electrons, then we call it a molecule. Let me know when we're ready, okay? And this has worked about half the time, by the way, today. We've run this experiment, this lab, many, many times. In some cases, the students weren't listening. I have a part in this. I'm going to explode it because I don't want you holding it in case the glass breaks. I'd rather cut my hand than see your hand get cut. So I'll hold the glass, too. I'm going to hold the glass, and I'm going to come around and blow up the hydrogen. If you have a cell phone on you and it gets ruined in this lab, it's your own fault. And I'm recording it. I told you to put it away in your book bags. You shouldn't be hiding in the cubby hole. Let me tell you right now, you have no one, I'm saying it for the record, you have no one to blame but yourself if your cell phone gets ruined. We had one cell phone get ruined earlier in the morning. We had one set of headphones get ruined.
How bad it got ruined?
They're no good. They're going to have to replace them. I told you all. Look how quickly they get up to go put their stuff away. It's so funny. Unbelievable. So if the glass shatters, I want to be holding it, ladies. It makes you nervous. You're not paying attention when I'm trying to explain the background that you're going to need to write your report. Your report's going to be worth 300 points. It's already in Schoology, gentlemen. The assignment's already in Schoology. You're not going to have the background to be able to answer the questions unless you're paying attention. And what's worse is there's some safety things that you really need to pay attention to that I would really appreciate it if you listen to. So when we're talking about a molecule, you're talking about something that shares two or more atoms that share electrons. Stop playing with the equipment. Start writing notes. Oh my God, it's like, I don't know. Give me strength, Jesus. All right. You have in front of you a tub. A tub. In that tub, there is water. Now, pure water does not. Everything good?
Yeah.
Thank you. Pure water does not conduct electricity. So pure water does not conduct electricity. It's an insulator. It will not allow electrons to flow. It blocks electrons. That's why another thing that blocks electrons is rubber or plastic. So all your electrical cords have what around them? Plastic or rubber. The metal conducts electricity, conducts the electrons, allows the electrons to flow, but the rubber, the plastic doesn't. Why is that important? Well, you don't want to get shocked, right? So electricity, when you feel a shock, what you're feeling is the flow of electrons. You're literally feeling that movement of electrons through your skin. So we have to add something called salt. By the way, I want to be clear about this because I don't want you thinking you could use water to insulate yourself. All the water you're exposed to in nature, all the water that you drink, all the water in puddles outside, your bathtub water, the water in your water bottles that you buy at the store, all of them have enough salt in them to conduct electricity. It will conduct electricity. You will get shocked. You have never seen pure water. Pure water takes a whole process. Purified water or distilled water is just not as salty. Is that clear? It's not pure water. So this water is distilled, but we added salt to it. This is the salt I added to it. And it says when I bought it last night, I bought it because it says, read with me, pure Epsom salt. Pure. But then it says, the part that I didn't read, it's the only Epsom salt I could find, so I bought it. It says, but then later it says, with lavender oils. If it has lavender oils in it, then it's not pure. By definition. So this is annoying that it says Dr. Teal's pure lavender, pure Epsom salt. So we know it works. So we added Epsom salt to this water already before you came in here. My assistants and I. Shh. And what we added to it, this Epsom salt, let's look at what it is. Okay, let's look at what it is. Epsom salt is made of two things. One thing is positive, has a positive charge. The other thing as wow, we're gonna keep just go ahead and have your conversation, huh? No matter what I say to you, it just gets positive. Let me spell it out. Well, it's because he's not listening. Honestly, it just boils down to people not listening, or maybe you're trying to listen, you can't hear, or whatever. But if you can't hear, it must be because other people aren't listening. So it all boils down to people not listening. So this side, let me just write it down here. This side's positive. And this side is negative.
How do you get negative water?
See, you haven't been hearing me at all. Because they're not talking about water. We're talking about salt here. It's okay. Okay, stop. It doesn't matter. I understand you don't understand, but again, you don't understand because you have not been giving your full attention to what's going on, for whatever the reason. It's impossible. I literally just said, water's blah, 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 blah. That's what you heard, right? Water, blah, 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 blah. No. Then I said, my assistants and I added salt. And let's look at salt. And we can see that we have, in salt, you have two things. You have a positive and a negative. And then you just asked, how do you get a positive or negative in water? Okay, so let's try it again. Let me be clear. We're talking about salt here. The salt that we added to the water. There are many different kinds of salt. You are used to sodium, which is an atom with a positive charge, and chlorine, or chlorine. It's actually chloride, which is negative charge. This is table salt. You've also seen rock salt, which usually it can be calcium plus 2 and chloride. So these are two salts that you're used to. You're used to it. But there's many different kinds of salts. Salt just means two things, two separate things. They're not sharing electrons. Please notice, do you see a line between these? No. This one's fully negative, not partial. You don't see the delta up there. This is not a partial negative. This is not a partial positive. They're fully negative. This is fully positive. And they're stuck to each other like magnets. They're not glued together with super glue. Covalent bonds are like super glue. Okay? These are stuck together like magnets. Yes.
Can you undo a covalent bond? Oh.
Yes, you're about to undo it. You're literally, this is what we're doing. This is electrolysis. Yeah, he's right. Pay attention. So sodium chloride, they're stick together. So now let's take a look at the positive. The positive in this salt called Epsom salt. A lot of you have heard of it. Epsom salt. Actually, it used to be called what it is, magnesium sulfate. Is an atom of magnesium, Mg, which has a +2 charge, has two positive charges, and another group of atoms, a molecule actually, of sulfate. Which has a -2 charge. So half of this salt is the negative side has more than one atom sharing electrons, but it has an extra 2 electrons. And the other half, this salt is just a single atom of magnesium. So essentially, when you're talking about salts, you can have a salt that's only an atom for the positive, an atom for the negative. You can have an atom with +2 charge and then 2 atoms of chloride, which would have negative charges each. They're not bonded with each other. They're just hanging around the calcium. Or you could have a molecule that's bonded together, but that has a -2 charge. And here you have a single atom with a +2 charge. What's 2 minus 2? 0. So this is neutral as long as they stick near each other, which is why that's why magnets stick next to each other, because the positive and negative want to be neutral. That's why magnets opposites attract. They want to be neutral. All right. So all that being said, we're going to add salt to water. And when you add salt to water, and I'm going to ask some of you to put some more salt in it. I will ask a volunteer to go around with the container. You can do it. And you can use the beaker and pour it in there so people get the full observational opportunity here. What you're going to do is you're going to add salt. When you add salt or sugar, right? Either one, to water, it disappears. Good. Who said that? Me. Excellent. Dissolves is the word.
He did not say that.
I know he didn't say that. I know who said it. I have to ignore some people. No, I'm just so glad that people do things are not slick about it. They just do it right in the open, even though they're being recorded. That's good. It leads us to having good conversations in the future. All right, so salt, you're going to add salt, and as you add salt to water or sugar to water, it disappears. When someone says disappears, many people think the stuff is destroyed, when actually it's not true.
Ain't it just breaking up?
That's right. Excellent. It's breaking up. What's happening is that the water molecule starts to surround one half of the salt. In this case, it would be the magnesium, but I'm just going to put a positive. Because remember we said magnesium is the positive. And magnesium is the positive. Sulfate is the negative. And so water will start surrounding it that way. And on the other side, the negative, let me use a different color because it's the negative, or maybe I need to. The negative is pointing towards the hydrogen. And so what you get is water starts, somebody said, isn't it broken up? And they were absolutely right. It is broken up. And it's broken up because water surrounds the halves. And water's able to do that because of something. Why is water able to do this? Break up the salt. Why? Why are the oxygen pointing to the negative? Ooh, I made that mistake. I apologize. That should be a positive. Why are the oxygen pointing to the positive and the negatives pointing to hydrogens pointing to the negatives? Why is that happening? Well, why are they opposite? Why is hydrogen opposite negative? What is? Well, kind of. The answer is what I already told you. I believe I told you. Maybe yes, I'm pretty sure I told you. At least you should have watched in the video. If you didn't, you were supposed to take notes on it, right? If you haven't taken notes, you haven't done your homework, you haven't read Schoology, you have a homework assignment. If you haven't turned it in, it'll be late. You'll minus points. A video was posted, right? It was posted 2 days ago. The assignments in Schoology, you were supposed to take notes and add anything you missed. 2 days ago. I'll tell you what. I'll give you a break, and let's have it done by Monday. But I should not have to do that. You should read your Schoology. So the positive, the hydrogen is, there's a polar bond, so they're not sharing evenly. This is a partial positive charge. This is a partial negative charge. This delta means partial. That means it's still sharing, but it's sharing unevenly. And in the example I gave is what would happen if you shared, what would happen if your mother went to you as the older sister and gave you your favorite food in the whole world and said, share with your little sister. All right, you boys are going to get detentions. So are you two ladies. They know who they are. I'm not playing around. I'm going to give you detentions, and there will be no conversation about it. I've given you enough warnings. I'm asking clearly for you to stop having these sidebar conversations. Clearly. I begged you nicely. I am now telling you, stop. So I said, what would happen if your mother gave you your favorite food ever, and you said share with your little sister or your little cousin? You would probably not want to say no because your mother would get upset with you. But what would probably happen is you'd probably eat most of it and give them a little bit of it, so that you can argue, I shared. Exactly. So, because oxygen is stronger than hydrogen, oxygen holds on to the electrons more as a partial negative charge. Hydrogen has a partial positive charge. So the hydrogen side of water is partially positive. It points to the negative, and the oxygen points to the positive, and it surrounds it. And to our eyes, salt isn't there anymore. Salt is there. If you put your finger in the water and tasted it, it would taste salty because there's salt in there. But you can't see it. You can't see it because the parts of it have been broken up, the way one of your colleagues said, broken up by the water. All right, so that's what we call that word that we use. That word is dissolve. Now, if you don't go back and revise this and add to it and think about it and reflect, then when you go back to study and you see the word dissolve and you didn't write any of that stuff I just said, and you look at this, you'll think, what does that even mean? I don't remember. Because you won't remember. So dissolving means to mix very well. You're just mixing it up really well. So well mixed that it becomes one solution. So we call this a solution. We call the salt a solute. So there's a solute. That's what is being dissolved. There's a solvent. That is what is dissolving, what is doing the dissolving. And there is a solution. That is the result, the mixture itself. This is the mixture. So when we talk about a solvent, we're talking about mixing a solution We're talking about looking at something that's so mixed up that you can't tell the difference between its parts. When you breathe in air, you're thinking air is one thing. It's not air is not one thing. Air is a mixture of things. Air is mostly nitrogen, some oxygen, some carbon dioxide, some smaller percent trace gases, some dust, some bacteria, some viruses, some mold spores. That's what's in air. It's a solution. It's a mixture. It's a mixture of different things. You take it into your lungs, you take the oxygen out, you put more carbon dioxide back in, and that's how you exchange gases through this mixture. Well, salt water is a mixture too. Salt water is made of water and salt. In this case, we're putting Epsom salt with lavender oil. Thank you. Okay. So now let's get to the lab. So what you're going to do is you're going to take water, shush, and be quiet, and shush. So you have water, which is H2O, 2 hydrogens and an oxygen, and you're going to break it apart. And this is what Adam was asking earlier, which is the whole purpose of this lab. Can you break up a covalent bond? The answer is yes. There's many ways to do it. We're going to use something called electricity. And we're going to break it up into hydrogen gas and oxygen gas. Now, the first law of thermodynamics tells us, again, part of what we had discussed earlier. It tells us that what we end up with, the products, has to be the same stuff as the reactants. All you can do is rearrange them. You can't create them or destroy them. So if we started with water, if we started with 2 waters and 1 oxygen, and we end up with 2 hydrogens and 2 oxygens, according to this, I'm creating oxygen. So I can't do that. So one of the things I have to do is go ahead and say I'm adding 2 water molecules. So that takes care of the oxygen. See, I have 2 oxygens because I have 2 water molecules. So let me draw it out. So if I have 2 water molecules, so there's 2 of them. Do you agree? Yes. And then I end up with hydrogen, which has 2 of these, 2 hydrogens bonded together, and an oxygen, which has 2 oxygens bonded together. These are both gases. My problem that I have is I have 2 oxygens. That's fine. There they are, 1, 2, 1, 2. I started with 2 oxygens. I ended up with 2 oxygens. But here I started with how many hydrogens? And there I have 2. Well, I have to have 4 on this side, so what can I do? Well, I would draw it out this way. I'd have H and H, so I have 2 hydrogen gases. Do you see the coefficients I'm drawing? That's what they mean. When you see the coefficients, they mean I have 1 hydrogen, 2 hydrogens. When you see this coefficient here, this 2, that means I have 2 water molecules. 1 water molecule, 2 water molecules. And when there is no coefficient in front of it, notice there's nothing in front of this, that means there's only 1. So 1 oxygen gas, which is 2 oxygen atoms bonded together, and 2 hydrogen gases, so that's 2 hydrogens bonded together times 2. That's what that means, right? From algebra, you know that. A coefficient in front of a variable means multiply. And here you have water. You have 2 times the water, so 1, 2 waters. So now it's balanced. So we have water. What we want to do is split it apart. How do we split it apart? We shove a bunch of electricity into it. Well, water is an insulator, so how can I make sure electricity flows? I add salt, Epsom salt, sodium or magnesium sulfate. So you're gonna take a battery which has ions in it. It's a rectangular battery. The reason we're using a 9-volt battery is it has nice nibs that allow you to hold a test tube over it. And you'll see why we need a test tube in just a second. So these nibs are very important. And of course it's square, so it's flat, it has a flat bottom so that we can, since we have a flat bottom, you can just sit it at the bottom of the water. You're going to hold the test tube over it like this. And another test tube is going to be over this one. Now, one of these is a positive and the other is negative. You know that's true, right? You've seen batteries before, is that correct? Yeah. All right. So you know that one side is positive and the other side is negative. Now, when you break water up, when H2O becomes, when it first gets broken up, it becomes O -2. So it's just a single oxygen atom with -2 and a hydrogen atom with a +1. Now, when it's first broken up, because of the electricity, when we break these bonds because of the electricity, where's the oxygen going to go? To the positive or the negative? To negative, because opposites attract. And so when you first break it up, you're going to get little bubbles, right? Bubbles of oxygen, do you agree? You have little bubbles of oxygen. It's going to start forming. Where's all those bubbles going to go inside the test tube? To the top. And what's going to happen to the water that's in the test tube? Not going to dissolve. As the gas comes in here and goes up to the top, what's going to happen to the water? It's going to be pushed down. It's going to be pushed down because of air pressure. Because the gas is pushing down on the water. Does that make sense? So the water level in the test tube is going to come down. Let's say it comes down to here. Okay? Now on the other side, you're going to get bubbles too. You're going to get hydrogen gas. So as this starts filling up with hydrogen gas, what's going to happen to that test tube? The water in that test tube. What's going to happen to the water in that test tube? It's going to go up again. And then what's that gas going to do to the water in there? It's going to push the water down. The gas is going to go up. The water is going to get pushed down. How far down? As far as oxygen, how much more gas is there? If I have more gas, it's going to go further down. How much more hydrogen do I have than oxygen when I break water up? 2 times. So I expect to see twice as much. I expect to see twice as much. So I expect the water level is going to be down this far with the hydrogen. This is hydrogen. That's my hypothesis. My hypothesis is that the hydrogen is going to form in here and that the oxygen is going to form in here, O2 gas or oxygen gas is going to form in that test tube. Hydrogen gas or H2 gas is going to form in this test tube as I break up water. And it's a violent reaction. You're going to see how many crazy bubbles it makes. You have to capture this, so you have to make sure the test tubes are filled with water. So, look out, girls, so that everyone behind you can see. You have to have this filled with water, so make sure it's all empty of air. Then turn upside down. Then once you have it like this, don't let it touch the surface again. You can lay it over the nib, right? The little nib here. Is that understood?
Do it again.
And one of them is positive and the other is negative. So you're going to take your test tube, which is full of air. Yours aren't because it's already underwater. You're going to stick it in there, make sure all the water's gone. Turn it upside down while it's still underwater. Now the water's in there. It's full of water. Do you see that?
Yeah.
So you put it on top of the nib, the positive nib or the negative nib. You do the same thing with the other one. So now you got these two nibs. One person's going to hold the positive. You put this in there, and it's going to be a violent reaction, should be. And you can see it is. And you put them over, and you start collecting the gas. As you collect the gas, the water gets pushed down. On one of them, you'll have hydrogen, and the other one, you'll have oxygen. Again, according to our hypothesis. I'll tell you in a second. Shh. We're never going to get to the blow up if we keep this up. Yeah. It's just water, man. Don't worry. Yeah? Yes. So there's a good question. How do you know the difference? The gas that's over the positive side, according to our hypothesis, is the gas that's over the positive side, according to our hypothesis, is oxygen gas. The gas that's over the negative side is the hydrogen gas. Now, when I come around with the lighter to blow it up in 15 minutes, if it's hydrogen, she just went, you have to wait. If it's an absolute emergency, we'll deal with it. But if it works well, I come around with the lighter, I put in the hydrogen, it blows up and makes water again. So we split them apart. If we do it right, we can put them back together again. We did it all day long. No reason why you can't do it right. Now, it's not all on you. Sometimes if I don't lift it up correctly, quickly, and I don't get the fire in there quickly enough, all the gas will come out. And it won't blow up, or most of it will come out. I think some of you are not going to be able to do this. You're sucking up our time. I only got 20 minutes as is because of all the wasted time we've had today. 20 minutes left in class, yeah. And you have 15 minutes because I'm not going to let you do stuff that you don't know what you're doing. So now you know what you got to do. Get your goggles on your eyes. Start collecting the gas. In 15 minutes, I'm coming around to blow it up.